Welcome to this video lesson on 3-4 transformations of linear functions. Today we are starting on page 165 in your textbook. All right, so transformations of linear functions. This is when we take a line on a graph and we move it around in different ways. And there is function notation that shows how we are moving the function around or the line around. We will learn about transformations again with different types of functions as we go through Algebra 1, but we always start learning about transformations with lines. So there's a very big learn box here today. What I want you to do is just put a bracket around it. So we're going to put a bracket right here. Okay. There's a few things I want you to underline as we go throughout. So this says a family of people in a group that includes people related by birth, marriage, or adoption who often share characteristics. Similarly, a family of graphs includes graphs and equations of graphs that have at least one characteristic in common. And we call the original function the parent function, and it is the simplest function in a family of functions. So I want you to underline this part here. So family of graphs includes graphs and equations of graphs that have at least one characteristic in common. The parent function is the simplest function in the family. Okay. The next part says the family of linear functions includes all lines with the parent function f of x equals x, which we also call the identity function. So this I want you to underline. F of x equals x is the identity function or the parent. Okay, next part is I want you to underline a transformation. Transformation moves the graph on the coordinate plane, which can create new linear functions or new lines. Next paragraph down, I want you to underline. A translation is a transformation. So this is a type of transformation in which a figure is slid from one position to another. And the very last thing, I want you to put a box around this little paragraph here. When a constant k, so a constant's a number, is added to a linear function, the result is a vertical translation. So that means we're moving up. The y-intercept of f of x is translated up or down. Okay, so let's take a look. Here is an example of a vertical translation. So if k, the value that we're adding to the function, is greater than 0, so if it is positive, go ahead and write that, positive, then we are going to move up on the y-axis. So if we were a little point here and we add a positive value, then we're going to go up here. Okay, if k is less than 0, so we're going to say negative. So if the value we are adding to our function is negative, and if we're a little point here, we're going to move down or slide down and end up here. Okay. Next page, page 166. We also have a scenario where we move horizontally. So when a constant h is subtracted from the x value, up here I want you to underline, subtracted from the x value, before the function is performed, the result is a horizontal translation. So we could move to the left or right. Again, if h is positive and we are adding it, we are subtracting it, from the x value, then we're going to move to the right. If the h is negative, we are going to move to the left. So sometimes these graphs are a little hard to interpret or understand. It's better once you actually see an example, which we're about to do. But before we do that, we're going to complete these statements. So these are the general function notations for each type of translation. The first one, we are adding k, and if it helps, replace f of x with y. Remember, that's just a fancy name for y. So here's our y, that's our x, here's our y, there's our x. Okay, that might help you a little bit. So when we add a value, a positive value to y, we know the graph is going to shift up. by k units. If we add a negative value of k to y, we know the graph's going to shift down that many units. If we subtract a positive value from x, we know that we are going to go to the right. And if we subtract a negative value from x, then we know we're going to go to the left. So we're making moves on the x-axis and the y-axis. Let's do an example to really understand what's going on here. So it asks us to describe the translation in each function as it relates to the graph of the parent function. Each of these examples is going to include a table, and this table is going to show you what's happening to the coordinate points as we move. So these are the x, these are the y coordinate points. We are subtracting a certain value and we end up with a new x and a new y coordinate pair. Okay, so we have our x values, our y values. We show what happens to the y value when we subtract something, and then we get a new x-y pair. All right, so they're telling us that we have this parent function and we are subtracting, and by the way, this is our parent function. So you can write parent. So this is the original function where you're starting with. F of x equals x, or y equals x. Now we are doing something to it. We are subtracting 2. We are subtracting 2. So we have g of x equals x minus 2. So the first thing we're going to fill in here is k equals, so the value we are subtracting by is negative 2. This means that our new function, g of x equals x minus 2, is a translation of f of x in which we added negative 2. So we added negative 2 to the parent function, and we got this new function, g of x. Okay, so what this is going to do is the constant k is not grouped with x, so this isn't going to be a horizontal move. So k affects the output. Remember, output represents the y values. Output, sorry, it looks like an A. Or y values, which that's what we see in the table. They are subtracting 2 from the y values, so y minus 2. All right, so the value of k is less than 0, so the graph of f of x equals x is translated. We're going to go down negative 2 units. Okay, so g of x, our new function, is the translation of our original function, or the parent function, f of x, by going down 2 units. So we start here on this line, and then we went down 2 units and ended up here. Okay, next page, page 167. Now we are changing the x values. So the graph of the parent function for the linear function is f of x equals x, just like in the last one. We have this new transformed function, which is g of x. And what we see happening is we have g of x is equal to f of x minus some value of h. So we see from the example, we have x plus 5. So we know that this transformation is f of x minus a negative 5. Okay. So our h value is negative 5, and then we have a transformation happening with the x. The constant h is grouped with the x, so h affects the, this time, input instead of output. Input or the x values, and you can see that in the table. X values. So here we have our x, and then we are adding x plus 5. So our function y times x plus 5 results in these new coordinate points. Remember, this is just your x, and this is just your y. So we see that this graph, if we're starting with the blue one, when we add plus 5 to each x value, we are moving to the left. So the graph of f of x equals x is translated -5 units to the left. Okay, try this check here. Look back at the example we just did, part A and B, and we'll go over that one in class. Now, sometimes you'll get an example where you have multiple translations combined into one problem. So here we are asked to describe the translation of this new function where we have x minus 6 and then we have plus 3 on the outside. And how does it relate to the parent? So we know that the parent function for a linear function is always f of x equals x. So this one is going to be, our translation is g of x, we see equals f of x minus some value h plus k on the outside. So that is just describing what we see happening. Now we're going to actually show the numbers. So h is going to be equal to 6 in this example, and we see that k is equal to 3. Okay, so h is equal to 6 and k is equal to 3. So the transformation that's taking place here is f of x is equal to, f of x minus 6 plus 3. So that is what is happening to our function. So the value of h is grouped with x and is greater than 0. So the graph of f of x equals x is translated 6 units. Since it's with x, it's going to be 6 units to the right because it is positive 6. Okay, then we have the value of k is not grouped with x and is greater than 0. So the graph of f of x equals x is translated. This time we're going to go up by 3 units. So 3 units up. Okay, so our new function is a translation of the graph of the parent function. First 6 units to the right, and then we moved 3 units up. You could always test that with a coordinate point. You could choose maybe this coordinate point here and see what happened. How many units did it move up? How many units did it move to the left or to the right? And that's what they show you up here again in this table. So remember, this is your y, xy coordinate points and what's happening to your points. You have your x, you're subtracting 6 first, and then you are simplifying and adding 3 to the overall result. And you're getting a new xy coordinate point. I want to mention just a few things about the other types of transformations, and we will go through these more in detail, but take a look at the dilation page. This is on 169. Here we see dilations, which are a stretch or compress of a graph of a function. So you can underline that top part, the stretch or compress of the graph of a function. And then I want you to annotate the page the way that I did here. So draw these little arrows showing how these two graphs matching up are similar and these two graphs matching up are similar. And then I want you to pause the video and write this out off to the side. This is very, very good for you to have because it's going to help you make the connections between the compressions and stretching. All right, we'll go through that some more, and I'm going to create some support videos for these concepts. Go to the last page in this video lesson is 171, and this is a reflection. So I want you to put a little bracket around this paragraph here. And then I want you to annotate the graphs the way that I did. I'm showing you the moves that these functions are making, how we are reflecting across the dotted line. We are reflecting this way across the dotted line and what's happening to our function. So it's when we flip it across the x or y axis, and that's what the little paragraph under learn says.